Hi and welcome to our 8th video about our DevSecOps pipeline which we are building with GitHub.
In this session, we're talking about DAST, Dynamic Application Security Testing.
In our past 7 videos, we had a look at our DevSecOps pipeline which we are building with GitHub. Hey Paddy, what have we done in the last 7 videos with our pipeline in GitHub?
Well, Romano, we started with a comprehensive look at what we're going to build into our pipeline. And the first tool we introduced was software composition analysis, so dependency analysis. We went also for license compliance, figuring out whether we trust the license or not. We also looked into static application security testing. There we basically looked at security issues our code introduced. We've made container scanning, where we looked for issues within our image or our container. And we've done secret detection, basically scanning for secrets like passwords or tokens within our code or configuration.
That's amazing, Paddy. But until now, as I understood it, we have statically analyzed our code and our configuration. But now we are going into the dynamic area. What is that dynamic application security testing?
In dynamic application security testing, we run our own application and then we attack our own application. This all is automated, of course, which means we need a tool that automatically scans and attacks our application that's running outside in the internet or within our premises.
So, Paddy, now we are on GitHub. GitHub is a continuous integration, continuous delivery pipeline, it's a platform. How do we do that with GitHub?
Out of the box, GitHub does not provide something that offers dynamic application security testing for us. This means we had to look for a suitable action and a suitable tool in the community. We finally found a solution based on the well-known OWASP SAP that was built or wrapped with the action full scan provided by the SAP team.
So this means that you can go to the GitHub marketplace and search for this GitHub action.
As mentioned, this action uses the OWASP SAP open source tool. As we use it, we do not add any of our own configuration, so we take it out of the box. As you can imagine, this means this is often not good enough for enterprise applications where you need to heavily invest into proper configuring your SAP. In our case, however, the standard configuration provided more and better findings than what we witnessed on the other platform we investigated. At the end of a successful scan, we upload a HTML report containing all the findings to GitHub. Our current solution, however, has severe drawbacks. First and foremost, the results, so the findings of OWASP SAP are not visible within the GitHub vulnerability management. The reason for this is missing serif support. Serif is the format that GitHub expects to get from tools in order to be able to display them in the vulnerability management. As mentioned, we also did not customize the sub configuration, which means findings are more like random. Plus, we decided to run the tests against a Docker container or a Docker image running and started within the pipeline and not deployed on Azure, for example, as a standalone web application.
But Paddy, you just said that we are going to run the Docker on our continuous integration, continuous deployment pipeline. But as I understood it, is it correct that I can also configure SAP to go to a real website where I have potentially deployed my application, for example, in the cloud somewhere?
Yes, absolutely, that would be possible. And in many cases, meaningful also. We just didn't do that to save us the time for deploying the application to Azure. Now let's look at the code and how we kind of implemented this. So welcome back in our project, and I'll just start the development environment here with the dot key. So here we are. Let's change to the file view and add a new workflow file here. So what I've added now is the configuration that actually executes this test. So the dynamic application security test or the penetration test. As before, this workflow can be started in two ways, either manually or automatically by our overall pipeline. So that's basically the two inputs here we have. Workflow dispatch is explicitly started and workflow call is started by the overall pipeline. What we require here in both cases is one parameter, basically the image name, the image that we want to put into a container, run there and test. The next thing we have is our already known two environment variables, the registry where our Docker image is, plus the image tag name. The image tag is basically what we receive as a parameter when called. Next, we have the job definition here, which we called dast scan, and we run everything on a Ubuntu image, which first checks out the container. After login to the registry and downloading the image, we do a Docker run where we execute this image in a Docker container. In the next command, we just wait for the container to start and we make sure that the container actually is responding in a meaningful way. Having prepared everything, we are now at the point where we can start our SAP scan. So basically we start the penetration test or the dynamic application security test run. We do this using the action full scan command provided by the SAP team. We again provide the Docker name of the image that will run Docker, provide some additional data, most importantly, at what URL the application we want to test is found. So what we define here basically as additional command line options we found here, which means we'll execute an additional Ajax spider to find more things, and we reduce the log level to warning in the console output. And we also prevent the action from opening an issue within GitHub for every scan. Opening an issue for every scan might be an option for a single person project or something like that. However, in an enterprise environment, you do not want to have that. So we disable this immediately. The next thing we do is we upload the HTML report to the results page of the pipeline run. And finally, we stop the Docker image and clean up everything. Please note that instead of just uploading the HTML report here, we would have preferred to upload a serif file containing all the findings. Because when using a serif file, we could integrate all the findings in the GitHub vulnerability management user interface. At time of recording, however, this was not supported and would have been developed by yourself.
So Padi, did I see that correctly? So when we go here, then we log into our container registry and we run our Docker container, which contains our application. So then we wait until it's really up and running. We make a quick test on that. And then we run a second Docker containing the OWASP sub2 Docker. And this Docker image then with the sub2 Docker is configured and tries to attack our application. And the findings are then again uploaded as a HTML into our CI/CD pipeline. Is that correct?
Correct. Now let's make sure that this dast step is called from the main pipeline. So let's see what I've added. So I've added a new job step that's based on build and Docker. So we need a finished Docker image and we call that on dast scan, obviously. And we just make sure that we call from here our workflow that we defined previously. And we pass in all the secrets we already have. And we pass in also the image tag. Now the image tag, that's something that our Docker job above here pushes out. So we say it needs from job Docker what it outputs as an image tag. Now let's commit and start the pipeline. So let's go back to our project. Now let's see what the pipeline run suggests. So we had the added dast pipeline, it finished. This is the new job we've added. And you see, set up the job, log into the container registry, then run the Docker image, wait for the container to start, and test whether the container actually returns something meaningful, which it does here. And then we run the full SAP scan. As we see here, most importantly, we can see what command was executed to run the scan. And we also see the most important findings it made on warn level in the console. After that, we uploaded the HTML version of the report to GitHub. And at the very end, we stopped our container and we logged out of the container registry. Now let's see what the report contains. Here at the end of the pipeline run, we see the artifacts list, which includes our dast report. When I open that one, we immediately see that we find a number of issues. Let's take an example here. So we have a cross-site scripting issue, obviously, which tells us that the URL echo, the message parameter, is not good. As we know from the code we've implemented and we've already discussed together, yes, that's true. It really contains a cross-site scripting vulnerability. So that's actually very good. We found it here. Now, as also mentioned, the sad part of the story is that this report is just available as an HTML report.
But Paddy, and we have now this HTML report, but we just saw that we have the option to add it as an issue in our pipeline. Was that not right? So that's far better than having just this report. An issue is absolutely great.
Yeah, well, take it that way. If it just provides us with an issue, then we have for every run, we have a completely new issue containing all the results found. If on the meantime, I actually resolved some parts or figured out that they are not relevant and mark them as not relevant, this will not be reflected by this kind of solution. So to be short, that's not an option we want to have in an enterprise solution. It's not usable and people will ignore it after just a few days.
Okay, Paddy, I got that. That's not really a good solution. But for the people which have their community projects, this could be a solution. Could you quickly show me how that works?
Absolutely. So let's head over to the code again. Open our pipeline file, namely our Dast configuration, edit it. And the only thing we need to edit is the allow issue writing flag and commit the whole thing. So now let's see what our pipeline did. Yes, it did run. And what we also see is that we have a first issue created by the action, which is the SAP full scan report. Let's open that. And this is what we see. We basically see the list of issues found or problems found, and that's it. We could assign this now to somebody, but as mentioned, the problem with this is that it always reports everything again, and it has no knowledge of what you already worked with or decided that it's no problem or a false positive. What we instead were looking for is in the security tab an entry such as we have for code scanning or even as part of code scanning, where we have then a finding that we can also manage, like dismiss or figure out what we should do there.
So we are now at the end of our video, and what we just saw is how we do dynamic application security testing. In application security testing, we do the following. We run our Docker image with our application, either on our pipeline, but when you have an enterprise application, then this will be on the cloud. So you also need to deploy this image to the cloud first. Then we run on our CI pipeline another Docker image, which is the OWASP SAP Docker image, which then tries to attack our application. The vulnerabilities that are found are stored in an HTML file, which we can upload into our CI pipeline repository. The drawback which we have with Dast is that it is quite complicated to configure it, and the second drawback is that we only have this HTML report, or we have that issue that we just saw where you have all the findings in there, which is not really good for enterprises. And with that, we're at the end of this video. In our next video, we will have a look at vulnerability management.